Assalamualaikum dan selamat sejahtera. The objective that we get from the practical task is, first one is to experimentally verify the triangle construction or parallelogram law of vector addition by using a force table. Second one is to understand the basic concept of force vector. Third is to draw the force vector diagram. And the last one is to find the analysis, the resultant force and direction the direction from force vector diagram. Introduction and theory. Introduction of a variety of quantities that are used to describe the physical world. Example of such quantities include distance, displacement, speed, velocity, acceleration, force, mass, momentum, energy, and anything else. All these quantities can be divided into two categories. The first is vectors and the second one is scalar. A vector quantity is a quantity that is fully described by both magnitude and direction. On the other hand, a scalar quantity is a quantity that is fully described by its magnitude. The emphasis of this unit is to understand some fundamentals about vector and to apply the fundamentals in order to understand motion and force that occur in two dimensions. Vector quantities are often represented by scalar vector diagrams. Vector diagrams depict a vector by use of an arrow drawn to scale in a specific direction. Vector diagrams were introduced and used in earlier units to depict the force acting upon an object. Such diagrams are commonly called as a free body diagrams. An example of a scalar vector diagram is shown in the diagram below. The vector diagram depicts a displacement vector. Observe that there are several characteristics of this diagram that make it an appropriately drawn vector diagram. Theory that we use is two: mathematical method and basic theory. Mathematical method, the most common two-dimensional solution of a force vector is into rectangular components where fx and fy are vector component of f in the x and y direction. Basic theory is a resultant versus equilibrium. A point to be aware of is that the force needed to balance the system is not the resultant of the weight, but the negative of that vector, also called the equilibrium. Thank you.
Hi guys, hello. For my part is I will tell you guys about equipment or apparatus and the procedure. So my equipment, we got 7 things. First is force table, second is pulley, third is hanger, fourth is weights, 5 is string, 6 is ring, and lastly is protector. For the, I will tell you about 5 function for the 7 things. Firstly is force table. The function of force table is a common physics lab apparatus that has 3 chains or cable attached to a center ring. The second is pulley. A pulley is a wheel on an axle or shaft that is designed to support movement. The third is hanger. Function of hanger is human shoulders designed to facilitate the hanging of cord or things that we do for experiment. The fourth is weights. The function of wakes is when performing assume integral of average to give some elements more wake. The 5 is string. The function of string is an array of character that the difference between a character array and a string is terminated with a special character. For the this next point is procedure. We got 5 procedure. Step 1 is set up the apparatus and material as shown in figure 1 below. The step 2 is hanging the right wake for each angle given and second the direction force and direction force valued refer table 1. The step 3 is record the data at the result table below. The step 4 is calculate all the forces acting on X and Y axis. And then lastly is step 5 is repeat the experiment with data given on table 2. For the next part is
My name is Muhammad Alif Muhammad Saman. My part is result and data analysis. Table 1 symbol F1 mass 100 weight 100 9.81 981 angle 112 angulation CW. F2 95 weight 95.9.81 resultant 931.95 angle 244 angulation CW. C3 mass 90 weight 90.9.81 784.8 784.8 angle 0. Table 2 symbol F1 mass 110 weight 110 9.81 107 9.1 angle 239 angle action CCW. Symbol F2 mass 110 weight 110 9.81 107 8.1 angle 1 to 1 angle action CCW. Data analysis. Force 1 0.981 direction tangent 0.8 second 119.99 magnetic force on X axis 0.81 cos 112 resultant negative 0.367 magnetic force on axis Fy 0.891 sin 112 0.909 force 2 0.932 tangent 1 resultant 94.04 magnetic force on X axis Fx 0.932 force 244 resultant negative 0.44 negative 0.409 magnetic force on X axis Fy 0.932 sin 244 resultant negative 0.838 force 3 0.785 tangent 0 cos 0.785 cos 0 resultant 0.7848 magnetic force on Y axis 0.785 sin cos sin 0 resultant 0 Fx resultant 0.0088 F1 resultant 0.071 force Fn F1 0.89 direction tangent 55 55.95, magnitude force 101.08 cos 239, resultant negative 0.56, magnitude force on x-axis 1085 sin 239, resultant negative 0.93, force to 1.08, tangent resultant 118 tolak 58.0108 cos 1 to 1, resultant negative 0.56, magnitude force on x-axis 108 sin 1 to 1, resultant 0.83, f3 108 1.08, tangent 0, magnitude force on x-axis 1.08 cos 0, resultant 1.08, magnitude force on x-axis 1089 sin 0, resultant 0, fx sama dengan 0.04 f.0. Thank you.
A vector is usually represented by an arrow where the direction of the arrow represents the magnitude of the vector. In 3 dimensions, a vector directed out of the page or along the positive z-axis is represented by a circle with a dot inside it. And a vector directed into the page or along the negative z-axis is represented by a circle with an x inside it. For conclusion, is the magnitude and direction of the resultant of several forces acting on an object was successfully determined using graphical addition methods. It was also proven using a force table that the resultant net force acting on an object at equilibrium is 0. Thank you.